So, more integrals. We're going to look at integrals of trigonometric functions. All right. So, for example, we know that the integral of sine of u with respect to u is what? What's the integral of sine? Negative cosine u. Yeah, watch those signs. Plus c. Please stop throwing papers. Okay, we are in class right now. All right, what's the integral of cosine? Sine of u plus c. Okay. What's the integral of tangent of u with respect to u? Nope, not secant squared. What's the derivative of tangent? Secant squared. What's the integral of tangent? We don't know this one. We don't know this one, okay? We do not know this one. But we can actually figure it out now, using what we know. So, let's do a little side work over here, and we'll figure it out. So, tangent of u with respect to u, okay. Do we know, we don't know how to integrate tangent, sorry, but we can rewrite tangent as what? Sine over cosine. Ah, yes. Sine u over cosine u du. There's no quotient rule for integration, remember? Okay. Good.
What did he say? Sine u cosine u negative 1.
What can we do here, though, to integrate this, now that it's written this way?
I would put cosine into the numerator with negative exponent.
You could do that, okay. Yep. I prefer to leave it like this. We're going to have to use a U-substitution, though. Let u equal what? Cosine u. Because what is the du going to be then? Sine u du. And I know this is like confusing because I used and stuff like that, but anyway, bear with me here. So we have sine u du right here. There it is. So that's going to be replaced with just du, and then cosine u is u, so it becomes integral of 1 over u du. Or as Austin maybe wanted to say, we can also write that as u to the negative 1 du, either way.
Wait.
Okay. Yeah?
But we already have a du in our...
I know, it was bad. I should have made this as tangent x dx and then done it that way. But you get the idea.
Yeah,
that's the point.
Okay.
Yeah.
I just wanted to make sure there wasn't going to be like...
No, it should really be like x's here. And this should be an x. And then this should be an x. And this should be an x. And then that would be x. And then that would be x dx.
I was just wondering if you were playing...
No, it's better. It's more clear that way. Okay. So, now, what's the integral of u to the negative 1? Is it, let's see, we got to add 1 to the exponent, so it's u to the 0, and then I bring the 1 over 0 out front, and so it's, wait, 1 over 0 is undefined. That can't be the way to integrate this. Yes, good. It's natural log, okay? Natural log of the absolute value of u plus c. Oh, shoot, I forgot. Gosh. The derivative of cosine is negative sine x dx. Sorry. So this is negative 1 over u du. Okay, sorry about that. Derivative of cosine is negative sine.
So is that negative ln?
So it's negative natural log of the absolute value of u, which then we plug back in for our u, and so it's negative natural log of the absolute value of cosine of x plus c. All right. Can I drop these absolute value symbols? Is cosine of x ever negative?
Yes, it is.
Yeah, so we got to keep the absolute values there, actually. And so going back to our little table we're making here, the integral of the tangent of u is negative natural log of the absolute value of cosine of x plus c. These will not be on tomorrow's quiz, but they will be on the next test. You will need to know that integral. Well, I'll be able to, like, do it. Yeah. All right. Let's do cotangent then. Well, you guys are smart. You can do math, right? You can see patterns. So sine becomes negative cosine, cosine becomes sine, integral of tangent becomes negative natural log cosine. So what do you think cotangent is going to be?
Negative sine.
So it's going to be natural log of absolute sine, but just that, positive. Positive natural log of the absolute value of sine of x plus c. That's right. All right, let's see here. Integral of secant of u. So just plain old secant by itself. Do we know how to integrate secant by itself? No. What secant do we know how to integrate, though? We can integrate secant squared. We can integrate secant squared. We can also integrate secant tangent. Right? Secant x tangent x is equal to secant. But integrating just plain old secant by itself, it is the natural log of the absolute value of secant of u plus tangent of u plus c. All right, and so then what do you think the integral of cosecant will be?
Cotangent plus cosecant.
So yeah, negative natural log of the absolute value of cosecant u plus, whoops, I'm like, well, it was going to be neat. Well, it was going to be neat. All right. Yeah, right, because I can't write.
We can't see it.
Sorry, scoot it over. There you go.
So,
okay, question? Yep.
Since secant is equal to 1 over cosine.
Yep.
Would it work out if we did the integral of 1 over cosine of u? Like, would we get the natural log of secant?
No, because you don't have your du then. If you let u equal like the denominator or something like you don't have the du as it's written. Just do 1 over cosine. It's not impossible. I mean, there is a way to manipulate secant. It's escaping me now how to do it.
Okay, but it's not something.
I think you multiply by sine over sine, I think, or something like that, and it maybe works out. But anyway, no, and then that's not right. I don't think either. But anyway, there is a way, and I think the book maybe will show the origin of it. But I just wanted to show you the tangent one. All right, let's see here. What else? Okay. There's a familiar one, right? We know this one, or we should know it. It is what? Tangent of u plus c. And what's the integral of negative? Wait, do I want to have? Nope, not negative. Sorry. What's the integral of cosecant squared of u du? And negative cotangent then plus c. Sorry, that's supposed to be a positive cosecant squared. Integral is negative cotangent u. Okay. And then we also have some more familiar ones. Secant u tangent u du. That's just secant u plus c. And then the integral of cosecant of u cotangent of u du is negative cosecant u plus c. Okay? And that's all the trig.
So,
yes?
So the derivative of like ln secant u plus tangent u plus c would be secant u?
Mm-hmm. When you take that derivative, it would be secant. It would simplify to secant u. Yes. Yes. Okay. So now we know all 6 trig function integrals. All right. These are your new ones right here. All right, you should have already known these two and then these four down on the bottom. Or if you don't, now you need to know them, okay, for sure. All right, but we have four new ones. All right. Secant and cosecant, in my mind, are actually pretty easy to remember because secant, and I know it's kind of going backwards because I know we're integrating secant, but if you remember secant's derivative is secant tangent, well then you can remember that its integral is natural log secant u plus tangent u, right? Cosecant's derivative is negative cosecant cotangent, so its integral is negative natural log cosecant u plus cotangent u plus c. So you see there's still some relationships there, right? Integral of tangent's negative natural log of cosecant, and then cotangent's opposite that, natural log sine. Okay? So stuff like that. Okay. When you integrate and your answer has a co in it, then you know it will be negative. It's kind of like the reverse directions where if you take the derivative of a co, you end up with a negative answer. So the derivative of a co ends up with negative. Integrating something that with an answer of a co has a co in it, then it'll be negative. So this answer is negative cotangent, negative cosecant, negative natural log cosine, negative cosine, negative natural log cosecant u plus cotangent u. Okay? Anyway, let's evaluate here. Let's get some practice in with this here. So 5x cosecant 3x squared dx.
So Brandon, ideas here. How can we integrate this thing? Okay.
You could take that u equal 7, that's gonna work right.
Well, let's see.
I guess so 3x squared. I guess it can work.
Okay, so what can we do with this 5?
You could bring out.
Let's bring that out front first here. Okay, so we'll let u equal 3x squared. So then du is going to be what there, Brandon? Yeah, 6x dx. Yeah, be careful with the dx. Don't forget that. Do we have 6x dx in our problem here? Yeah, we just have the x dx, right? There's x, there's dx. So what do I got to do with that 6? Yeah, make it 1/6. du. Divide both sides by 6, make it 1/6 du equals x dx. And so now I'm going to replace that x dx with 1/6 du. So the number out front is going to be 5/6 integral cosecant u du. Okay, very good. And Donovan, what is the integral of cosecant of u? Yeah, so it's going to be negative 5/6 natural log of the absolute value of cosecant u. Keep missing my c. Cosecant u plus cotangent u plus c. And then we'll just sub back in the original u there. And there it is. Okay. Questions on any of that?
Can you go back up to where the integral of cosecant was? I guess I might have miswrote it.
Yeah, it's kind of...
I didn't do plus cosecant.
yeah. All right. Let's try another one. Question, Ryan, or no? Just scratching.
No,
Okay.
just
All right. Integrate secant x tangent x minus 2 secant x plus tangent 2x. with respect to x. Okay. So how should we go about integrating this? Anna, what do you think? How can we go about integrate this? What can we maybe do? What's the strategy we kind of use here to integrate this big monster of a integrand? Let u equals what? Okay, we could do that. And so then du, the derivative of secant, is secant x, tangent x. So, like, this we can replace with a u. Oh, sorry about the dx. So we can replace this with a u. Let's see here. Well, we have tangent 2x, and that's not going to be dealt with here because we just have the tangent of x. And so use tangent x instead of that. So we do, but think a step back before U-Substitution. There's actually something we want to do before here to make this easier, and it's something that you did earlier in your problem set that I was helping you with. I see subtraction and addition here. What can we do when we have an integrand with subtraction and addition? Yeah, break it up. Yeah, is that what you're going to say, Tyler? Yeah, break it up. Did you not do it and still be able to get an answer? Well, that's what the idea is. That's what you did. You did break it up then. But yeah, I see what you're saying. You didn't rewrite it though, is what you're saying. Yeah, it's fine. Yep. I'm also gonna, so I'm breaking up over addition and subtraction. I'm also gonna move that 2 outside my integral here. Okay, so you can see it's integral secant x tangent x dx minus 2 integral secant x dx plus integral tangent 2x dx. And we can do that. Break it up to make it easier. Okay. Anna, what's the integral of secant x tangent x? Yeah, it's secant x, right? Because, I mean, think about it. That's what we wrote before, right? You just told me that the derivative of secant is secant tangent, so the integral of secant tangent is secant x. Minus. All right. Let's go to someone else here. Jack, what's the integral of 2... Sorry, what's 2 times the integral of secant x? What's the integral of secant of x?
Secant x.
Close. It's minus 2 natural log. This is one new one we learned.
Oh, yeah.
Okay, secant x plus tangent x. Plus, and now to integrate tangent of 2x, what do we have to use here? We need to use a U-Substitution here, because we can't integrate tangent of 2x. We need to do tangent of u, or tangent of x. So let's let u equal 2x. So du equals 2 dx. Excuse me, and then we have 1/2 du equals dx. So we end up with 1/2 the integral of tangent of u du. Okay. And yes, you can, when you integrate the individual pieces, you can like do these integrals and then still have an integral left to be done. That's okay. Okay. Once you've done the integral, though, you want to drop those integral symbols, right? Should not be rewritten anymore. And that is important that you do that, because otherwise, if you don't drop them, you're not showing correct thinking. Bless you. Bless you.
Thank you.
Okay, so the integral of tangent is what there, Chanda? Negative natural log cosine. Yeah, don't forget the natural log part. So yeah, negative 1/2, in this case, absolute value of cosine of x. And then plus c.
So, for answer 2x, they're doing these, so is that like a principle that you can apply by like just taking out the coefficient of the tangent, turning it into the inverse?
Yeah, yeah, you can.
It's just simple.
Because you basically just did like a quick U-substitution, like, yeah.
Wouldn't it be cosine of 2x?
Thank you. Sorry, cosine u is what I should have here, and then I'll plug it back in finally. Secant x minus tangent 2, natural log, secant x. Oh, see you guys later. Plus tangent x, absolute value, plus negative 1/2, natural log of the absolute value of cosine of 2x plus c. Some of you guys are like, I wish it was done by this point.
So, would it is correct to like leave these out until the very end, so like, should you put like secant x plus c?
I technically, yes, thank you for asking that, Brandon. That's a very good question. Yes, technically, once I've integrated here, I should have a little plus c written in there. You don't need to write it for both. One is just fine, but yes, technically you're right. And in fact, I may have just maybe lost you guys some points by showing it to you that way, by not putting the plus c in there. Once you've integrated, you need to have that plus c in there at some point. You need to have to integrate anywhere, and then, again, you can keep it all together as one c, though, in the entire problem. So, yes, Ryan?
Where did I did it sort of differently? Where did the two, where you have the integral of, it's like pretty much negative 2 secant x dx
Yep.
in the middle on the top. Where'd the 2 come from where you put it out there? Where'd that 2 come from?
The original problem was minus 2 secant x.
It is. Oh, I just missed that.
Yeah,
Okay.
so that's all you missed. So there it is. Okay, guys, that's the answer. Voila. All right. I think I'm going to have us stop there, and we'll continue this tomorrow after the quiz. Okay, so we'll stop there. I'm going to give you guys a short assignment here, I think, for tonight, because I know...
But